So in lesson 8.2, we are going to look at some triangles that are not right triangles. Okay, so particularly we're going to look at what's called the law of sines, and these are for oblique triangles, and usually they have an obtuse angle greater than 90 degrees, but for definite sure there are no right angles in an oblique triangle. And we have a set of ratios that can help us finding lengths of sides and measures of angles of oblique triangles. And this is just saying that if we have a triangle that's labeled for angles A, B, and C, and the sides opposite of them represent the lowercase letters for A, B, and C, that the ratios are equal. So here I have sine A over A, length of side A, sine B over length of sine B, and sine C over the length of side C. So I can take any of these ratios and set them equal to another ratio, and that would form a proportion. Okay, so I can take the parts for A and B and set them equal to each other. I can do B and C, set them equal to each other, or A and C. And that's what this just says down here. So in this first example for figure 21, it says solve the triangle. Now we did this with right triangles, same process. If I'm solving a triangle, I have to find the measures of all the angles and the lengths of all the sides. And if I look at this, I have information here. I know A is 40, B is 60, and side A is 4. So if I look at and just kind of go around the triangle, I have an angle that I know, an angle, and a side. So if we remember back to geometry, we talked about triangles and different information that we know. And if you remember, there were theorems about angle, angle, side, side, angle, side, 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 side. Okay, so this is just a triangle that is described by an angle we know, an angle we know, and a side we know. All right, so knowing that I have an angle and a corresponding side that we know in the given, this is going to be one of the ratios that we use to find the other parts of the triangle. Now for angle C, this is actually pretty easy because remember they have to add up to 180 degrees, all the angles of the triangle. So if I take 180 and subtract the two angles that are there, side C is going to be 80 degrees. Okay, so that's one part down. For the lengths of the sides for B and C, we're going to set up proportions. One ratio is going to be sine of A, which is 40, so I'm going to do sine 40 over side length is 4, and sine of 60 over a length that we don't know. So now I can just solve this proportion, and remember I can do the cross products. So B times sine 40 equals 4 times sine 60. And to find the length of B, I'm going to divide by sine of 40. So I have 4 sine 60 divided by sine 40. And B, in this case, I have 4, sine 60 divided by, and I should close my parentheses there, divided by sine 40. And that gives me a length of 5.38. Let's call that 5.4. Okay, so that was the side B. So that's this side down here. This is 5.4. This is 5.4. And we're good with that. So we have one more length to find here. And I'm going to use this ratio again. So I have sine 40 over 4 equals, now I'm finding the length of side C. So I need to know angle C, which we said was 80. So I'm going to do sine 80 over length of side C. So doing the cross products, C times sine 40 equals sine 80 divided by 4, sine 40. I'm just moving that down there. Whoops, I skipped a part. There we go. 4 times sine 80, and then I want to divide by sine 40 to get C all by itself. And in that case, I have 4 sine 80 divided by sine 40. 6.12 or 6.1, and that would be that side right there. And this is 6.1. All right, so we know all of the parts of the triangle. Next one says to solve the triangle. So we'll do the same process. This time we have an angle, a side, and an angle. So this is angle, side, angle. And when that happens, we are using these ratios again. So if I put down what I know A is 35, B is 15, C is 5. All right, so I don't have a pair of corresponding parts that are given, but using the sum of the angles equal 180, I can subtract 180 minus 3, 4, 50, and that's going to be 130. So it's angle C right here is 130. Now I'm going to use these parts with the ratio for each one, A and B. So I'm going to have sine 130 over 5 equals sine 35 over A. Doing the cross products, I have A times sine 130 equals 5 times sine 35. Divide by sine 130. And A is 5 times sine 35 divided by sine 130. And I get 3.74 or 3.7. So side A is 3.7. And now I need to find side B. And for side B, we'll use the ratio of what I know. I could use these two, but I'm usually better off using the information that's given here. So I will stick with sine 130 over 5. And now for angle B, I'm going to have sine 15 over B. Cross multiply, so B sine 130 equals 5 sine 15. I'm going to divide by sine 130. And b, those cancel. 5 sine 15 divided by sine 130. 1.68, or I'll call that 1.7. All right, so side B is 1.7. All right, all the parts of the triangle we know. Now, when we get to what's called the ambiguous case, okay, so ambiguous means things can be a little bit different. This involves triangles where we know side, side, angle in that order. Okay, and remember back in geometry, you didn't have a theorem for SSA or ASS. So here we're going to talk about that a little bit. So if you have a side-side angle triangle, there are actually 3 things that can happen. First of all, if you know a side and an angle, the 2 sides, one of them may not be long enough to form a triangle based on the 2 sides and the angle. And if that's the case, there would be no solution. Okay. If you have a triangle where you have a side angle and it makes a triangle, okay, and that could be just 3 different pieces here, that means there's only one solution for the possibilities of those angles. So in this case, we'll say that there is one solution. And in some cases, you might have a case where you have an angle, a side, and you could make this side very short, where it goes from here to here, or you can make it very long just by swinging the angle the other way and making it a little bit longer. If this is the case, then there are 2 solutions. Okay. Now, a way that you can tell is when you find this angle right here, which would be across from the side that you know, we'll call that angle B. When you find this angle, the second solution, if there is one, is going to be a supplement of the first solution. So what that means is I take the first solution and subtract it from 180. And if that's possible, then there's 2 solutions. Sometimes it's not possible. And in this first example, I'm going to show you how. So here I have a triangle. A is 3, B is 2, and angle A is 40. So I know 2, I know 3, and I know 40. And I want to find the length of that side right here. So I'm solving the triangle A, B, C. So I know A is 3, B is 2, angle A is 40. So this is a ratio that I will use with the law of sines. And let's find angle B. So if I do sine of A, which is 40, over the length of the side opposite, which is 3, and then sine of an angle I don't know, which is B, over 2. If I do 2 sine 40 divided by 3, I'm going to solve for B here. So 2 sine 40 divided by 3 is sine of B. And to find the angle that has this sign, I'm going to do the inverse sine. Now on a calculator, if I try that, I'm going to do inverse sine, and I have 2 sine 40, close the parentheses, and then I'm going to divide that value by 3. And that angle is 25.4. So I know sine B is angle B is 25.4. I'll just write it over here. All right, so if there's another angle where I can maybe bring this side inside here, it's going to be the complement of this, the supplement of this. So if I do 180 minus 25.4, I'm going to get an angle of 154.6. Now this would be one of my angles in my triangle, and I still have angle A equals 40. So to find the third angle, I'm going to add them up and subtract from 180. Well, if I add these up, this is bigger than 180. Okay, so this is too big to fit with a triangle where the 3 angles add up to 180. So the supplement of 25.4 is too big to go with the other angle I have, let alone a third angle. So this one is only going to have one solution. So I should say up here I can have 1 or 2 solutions. Okay. So now I know that I still need to find angle C and side C. Well, angle C would be the leftover amount if I subtract these from 180. So if I take 180 and subtract 40 plus 25.4, that's 65.4. That angle is 114.6. All right, so angle C, 114.6. The length of side C is going to be, we need to do a ratio here, and I'm running out of room. So let's do that over here. So I'm going to take my sine 40 over 3, and I'm going to set that equal to sine 114.6 over side C. All right, so I'm running out of room, so I'm going to kind of condense my steps here. So I'm going to multiply by C over on this side. And I have sine 114.6. I need to multiply 3 to get it over here, and then I need to divide by sine 40. So I have 3 times sine 114 divided by sine 40. 114.6 divided by sine of 40. And that would be 4.2. So that's the length of that side right here. And I can fill this in here too, 4.2 for side C. All right, so in example 4, here I have angle side side or side side angle, and it says that my angle is 35. My side A is 6, my side B is 8. So I need to find the measure of side B. So to do that, I'm going to use my A's as 1 ratio. So I'm going to do sine 35 over 6 equals sine B over 8. And I'm going to solve for B. So I have 8 sine 35 over 6 is sine B. I want to do the inverse sine of all of this. So on my calculator, I'm going to do inverse sine of 8 sine 35, close the parentheses, divided by 6, close parentheses again, and I get 49.9. So angle B, 49.9. Now, again, it's possible that there be 2 angles. If I find the supplement of this, which is 180 minus 49.9, I get 130.1. So if I take 130.1 and add 35, this is my second angle. That measure is 165.1, and I haven't gone over 180 yet. So I can have a third angle. This is A, this is B, sorry, other way around. This is angle A, this is angle B, and I would have an angle C that would be 180 minus the sum of these two would be 165.1, 14.9. All right, so I can have this big triangle be one solution, and I can have this little triangle be another solution. So I do have 2 solutions here. I'm just kind of color coding here. If 49.9 is angle B, that would be this angle right here, then side B is 8. This is the big triangle. The side opposite is 8. Angle C would be 180 minus 35 and 49.9. So angle C would be 95.1. All 3 of these angles add up to 180. And now, if I find the side C that's down here, across from angle C up here, this side is going to, we're going to do some ratios again, where I take the A's. So I have sine A, which is 35 over 6, and that equals sine C, which is 95.1, over side C. So I'm going to multiply by my cross products. So I'm going to have C equals 6 times sine 95.1 over, and I have to divide by sine 35. Okay, so I did my cross products. I have C times sine 35, 6 times this. Then I have to divide by sine 35. And when I calculate that, C is going to equal 10.4. All right, so if angle B is 49 degrees, I have these values for angle C and side C. However, A is still 35, A is still 6, B is still 8. If this B is the the supplement of 49.9, and we said that that would be 130.1. So if B is 130.1, I need a new value for C. So 180, oh, we found that, 14.9. So this angle right here would be 130.1. This angle right here would be 14.9. Now I need to find side C, which would be this side right there. All right, so I need to find that side. I'm going to go back and use this same ratio, angle 35 and side 6. So 35, opposite side is 6 right here. So sine 35 over 6 equals sine 14.9 over the length of side C, which is what I want to find. So I'm going to solve again. So I'm going to multiply C over here, and 6 times sine 14.9. Then I got to divide by sine 35. And if I do those calculations, I get 2.7, which would be this length right here. Right in there. All right. I know that was probably a little confusing. We'll look at another one here in a minute. But then in example 5, we have a description of a triangle they want us to solve. So I'm going to write down all the parts. There we go. I'm also going to draw a triangle, and it's not to scale, but I'm going to label my sides, and I know side A is 2, side C is 1, so A is 2, C is 1, and angle C is 50. So this is one of the ratios I want to do, and let's find the length or the measure of angle A. So if I start with sine 50 over 1 equals sine A over 2. So sine A equals 2 sine 50. Now to get the measure of angle A, I need to do inverse sine and on my calculator, I'll do inverse sine of 2 sine 50, close the parentheses and close the parentheses again. I got 2 sets of parentheses here. And I get an error message. Okay, and my error is something to do with the domain. So if I look at the value of 2 sine 50, it's 1.53. So this value right here is 1.53. And I want to know what angle has a sine of 1.53. And if you remember, all of our sine values have to be between -1 and +1. So this is too big. Not in domain for sine. All right, so if that happens, this is a case where there's no solution. Okay. And the last one. In example 6, it says we're going to measure the height of a mountain, and the surveyor takes 2 sightings of a peak at a distance of 900 meters apart. All right, so looking at this, here's the mountain. Here is the surveyor's first measure. He takes a measure of the mountain, then he moves back 900 feet. And he takes another reading. The first measure had an angle of 47 degrees, and when he moved back, he had an angle of 35 degrees. If the transit, now the transit is the device that he's using to measure the angle. So if the transit is 2 meters high, so it's like the person is standing up and their height is 2 meters, I want to find the height of the mountain, which starts down here. So whatever I get for this height, I have to add the 2 meters to it. All right, crazy little thing at the end. So sometimes when I see problems like this that involve 2 triangles, sometimes I like to separate the triangles so I get a better look at what's going on. So first thing I need to do is, if I want to find the height, I need to know either the length of this side right here, and that way I can use the big triangle to find the length or the measure of the height, or I can find the length of this side right here and use this small triangle or the medium-sized triangle to find the height. So in any sense, to find this length right here, I'm going to use the small triangle because I know that this base right here is 900 feet. And let's look at this. So this is 900. I know this angle is 35. And if I were to want to use 900 with my law of sines, I need to know this angle. There's nothing up here that can help me get this angle, but I can find this angle. This angle inside here is going to be the supplement of 47. So this is going to be 180 minus 47, and that would be 133. So this little angle, or this big angle inside here, is 133. And by using the sum of the angles add up to 180, I can find that this angle is 180 minus the sum of these 2 angles. So this would be 158, or 168, sorry. So this angle is 12. So now I have a ratio of 912, and I can find the length of either side. So let's find this side right here. And this is opposite this angle, so I'm going to call this side B. So if I do sine 12 over 900 equals sine 35 over B. That's a little b, sorry. So now I'm going to do my cross products. I'm going to have b sine 12 over, or equals 900 sine 35. Now I'm going to divide by sine 12 so that these cancel. Whoops, sorry. So now I have b equals 900 sine 35. That's what it was, right? Yeah. And then divided by sine 12. That gives me 2,482.8. So let's make this 2483. So the length of this side right here is 2483. Now, this side right here, 2483. And if I look at this triangle right here, I'm going to just draw that separately. And remember, this goes down, this is 2 meters here. This is 2 meters high before he's measuring. This angle is 47, and this is 2483, and I want to find this height. Now, couple things. This now is a right triangle. So I can use a trig ratio that involves the height, which is the side opposite, over the hypotenuse. So opposite over hypotenuse is sine. So if I do sine 47 equals h over 2483, if I multiply sine 47 times 2483, I get 1815.9, so 1816. So the height, or h, is 1816 meters, because we're measuring in meters here. But I have to add this 2 meters high that we're taking that measure. So that whole height of the mountain is 1816 plus 2, which is 1818 meters. And there we have it. All right, so we'll do some more practice with these, but I really think that instead of trying to fit everything in to one diagram, split the triangles up so that you can easily label the pieces that you have there.